Hello, welcome to video 1C. This video is about intercepts and symmetry. I'm Mr. Miller and I hope you're doing great. We're going to look at three examples and we're going to find the intercepts for the equations, and we're going to demonstrate the kind of symmetry it has. Alright, so here's our first example. It says find the intercepts and test for symmetry about the axis and the origin. So that'd be about the x-axis and the y-axis. Alright, our equation is 1 over the quantity x squared plus 1. And I actually have a graph here, so we can kind of tell already. This is cheating a little bit. But the graph kind of shows me that it has a y-intercept at 1. It doesn't have any x-intercepts. It never touches the x-axis. And it looks like it's symmetrical about the y-axis. But I kind of want to show that algebraically. Alright, so to find the y-intercept, remember that we set x equal to 0. Okay, so let me try to get my pen working a little bit better here. So when we put 0 into this equation, we get y equals 1 over 0 squared plus 1, which is 1 over 1, which is 1. So we get the y-intercept is 0, 1, like we said. It's right there. Show that algebraically though, or at least explain that algebraically. For the x-intercept, we set y equal to 0. We're looking for points where y equals 0, which would be points on the x-axis. So if we put 0 in for y, we get 0 equals 1 over x squared plus 1. This looks a little complicated, but you got to remember, this is kind of like a fraction. In order for a fraction to equal to 0, the numerator has to equal 0. And the numerator is 1. It's never equal to 0. So there are no x-intercepts. Okay, so let's check for symmetry. Now, I'm just going to discuss the symmetry we see that it has in the graph and prove that it has it. So in order to check for symmetry about the y-axis, like my little table over here says, we replace x with negative x, and we see if the equation's the same. So I'm going to do y equals 1 over, I'm going to put negative x in instead of x squared plus 1. Okay, negative x squared is the same as x squared. So if I simplify this, I get 1 over x squared plus 1. Kind of lost my place here. There we go. Having a little trouble today. All right, now, when I replace x with minus x, it turns out that the equation simplifies to be the same thing. So if I put minus x in, I get the same thing as if I put x in. For instance, if I put 1 in, I'll get this value right here. But if I put negative 1 in, y equals the same thing. Okay, so, alright, so I have symmetry about the y-axis. So again, I use the middle test here. Alright, let's move on. Okay, here's our second example. So we want to test for, find the intercepts here. So to find the y-intercepts, again, set x equal to 0, we get y equals 0 to the third power plus 0 equals 0. So the y-intercept is 0, 0. So I see that's the origin right here. So that turns out that that's both a y-intercept, where it crosses the y-axis, and it's an x-intercept too. Okay, it's the only x-intercept. Now I could show that that's the only x-intercept algebraically. So remember, we put 0 in for y when we're finding the x-intercept, and we get x cubed plus x. Alright, this is kind of a cubic equation, and those can be nasty. You just try to factor it. So first start by factoring out the greatest common factor. X times x squared plus 1. This actually doesn't factor anymore. So if I use the zero product property, I get x equals 0, or I get x squared plus 1 equals 0, or x squared equals negative 1, which can't happen. Alright, so the square of a number is 0 or greater. If we took the square root of both sides, we get the square root of negative 1, which is an imaginary number. So again, I see that the only x-intercept is x equals 0, or the origin, which I had already. Now, symmetry about this graph. It does have a symmetry. It's not symmetrical about the y-axis. It's not symmetrical about the x-axis. It's symmetrical about the origin. And you can see that this point right here will correspond to that point right there. If you turn this graph 180 degrees, like upside down, this point will lie right on top of this point. Alright, so the test for symmetry about the origin. You replace x with minus x and y with minus y. So here we go. I'm going to replace y with minus y and x with minus x cubed plus minus x. Alright, so we get minus y equals, when you cube a negative, you get negative. It's like negative 1 cubed is negative 1. And then plus and minus x is the same as minus x. I'm going to divide by negative 1, and we get y equals x cubed plus x. So I end up with the same equation I started with, which means that it's symmetric with respect to the origin. So that's this case right here. Replace x with minus x, y with minus y, and see if it works. So for instance, this point right here was 1, 2. It's on the graph. Notice that the point negative 1, negative 2 is on the graph also. If I replace the coordinates with their opposites, I get another point on the graph. Okay, time for our third and final example here. Alright, so we have absolute value of y equals x plus 5. Alright, just looking at the graph, we see it has 2 y-intercepts, 1 x-intercept, and it's symmetrical about the x-axis. Alright, let's show all of that. So for the y-intercept, set x equal to 0. So we get absolute value of y equals 0 plus 5, or absolute value of y is 5. If you think about it, there are two numbers whose absolute value is 5. The absolute value of 5 is 5. The absolute value of negative 5 is 5. So we get two y-intercepts, 0, 5, and 0, negative 5, just as shown in the graph. So, alright, both of those have absolute value 5. The x-intercept, we get that by setting y equal to 0. So the absolute value of 0 equals x plus 5, or 0 equals x plus 5, or x equals negative 5. So we get negative 5, comma 0, which is right there. Alright, I want to demonstrate algebraically that this graph is symmetric with respect to the x-axis. And I'm having trouble kind of marking it here, but that's the top test there. To do that, we replace y with minus y. Alright, so let's try it. I'm going to put absolute value of minus y equals x plus 5. But the absolute value of minus is plus. So this would just be the same as absolute value of y. Alright, that negative is not going to matter when I take the absolute value. It's kind of like when you square a negative. It doesn't matter. So this is equal to x plus 5, which is the same equation I started with. So it has symmetry with respect to the x-axis. So if I have a point like here at negative 2, 3, okay, that means I'm also going to have a point at negative 2, negative 3. So if I just replace the y value with its negative, I get another point on the graph. Okay? Alright, so that's symmetry with respect to the x-axis. Alright, time for the journal assignment. So consider the equation below. Y squared equals x plus 9. So find the x and y intercepts, and B. This graph is symmetric about the x-axis. I want you to show why algebraically, kind of explain why, by doing the appropriate tests for symmetry about the x-axis. All right, good luck. See you in class.